Well, hello everyone and welcome back to Adrian's Digital Basement. On today's video, I'm back on the Amiga 3000. On the last video, which I recommend you watch before watching this one because we're continuing the repair saga of this machine. That last video went totally off the rails, where this machine, which I thought was going to be an easy fix, was anything but. What started off with just repairing some battery damage seemed to escalate into the machine kind of working, but then getting worse and worse, where I could no longer boot Kickstart 2.04 anymore. So in this video, I want to try to explore what's going wrong with this thing and see if I can get a little bit more answers as to what might be wrong with this thing. The Amiga diagnostic ROM that's out there does run without any issues on this machine, so this is something specific to Kickstart 2.04. And in today's video, I think we're gonna take a little bit of help from the AGFA CompuGraphic 9000 PS to try to get some code running on this Amiga that can maybe give us some better answers as to what's going wrong with it. So without further ado, let's get right to it. Before we get started, just a couple small housekeeping items. First off, I started working on this video, part 2, before part 1 went live to anyone. So even though when I finally posted part 1, there were some obvious answers as to what was going wrong with the computer and why I got stuck that people commented on, and thank you very much everyone for that. But as I started to work on the Amiga to try to figure out what was going wrong with it, and that's what you're about to watch in this video, I was operating without that information. Although, while I was making this video, part 2, I did put the video, the first one, live to my patrons and YouTube members, and they pointed out some of the stuff that was also in the comment section on the public video on the YouTube channel. So once I realized that stuff, I took that to heart and then I kind of ran with it. But I just want everyone to keep in mind that when you are working on something that you are not really familiar with, and there isn't a ton of information out there, because believe me, I did Google for the problems I was having in part 1, which was specifically the machine seemed to work fine with the Kickstart 1.4 ROMs, that were those ones I found in my stash, but then it didn't work with the 2.04 ROMs or the 3.0 ROMs, and looking online for that, I didn't really find any solutions, even though now, when I know what to look for, which you'll see watching this video, the answers are more forthcoming. But whenever you're working on something that is sort of unknown to you, and I'm working on stuff like that all the time, you kind of have to use your best judgment as to try to figure out what might be going wrong. And with complex things like computers, and especially the Amiga 3000, it's a 32-bit computer, there's a lot that can potentially go wrong that can get you hung up. And instead of just cutting that out of the video, I leave that stuff in there so you can kind of see the struggles. And that's what you're going to watch me go through here. Moving on to the other housekeeping item, I just want to mention that VCF Southwest, that's going to be in the Dallas-Fort Worth area. That is coming up very soon, and I'm going to be attending that show. So I'll put the dates on the screen here. So if you're in that area and you want to come to VCF, and it's a pretty fun show, I've gone a few times now, then come check it out, come say hi, and enjoy all the retro splendor that will be available at their new venue, which apparently is going to be bigger, and there's an attached hotel and stuff like that. So with all that said, let's finally get to the video. So while I was waiting for the video to render on part 1 of this machine, I was sitting there thinking that it was kind of interesting that the original ROMs that I found in my stash came up with that super Kickstart boot menu. And it was actually working where I could, use the mouse and, well, I got an interface. I got something out of the computer. But I don't have the original floppy disk that came with this computer, including the super Kickstart disk. So I started doing some research trying to figure out exactly what that was. And apparently when the original 3000 came out, I think I had alluded to this in the last video, Kickstart 2.04 wasn't out yet. So they put this sort of temporary Kickstart on here, and it allowed you to either boot Kickstart 1.3 or 2.04 from the hard drive or from floppy disks. And there was a super Kickstart floppy disk that contained both 1.3 and 2.04, and you would boot that, and I guess you could, then boot the system, install the OS. It came with some additional bonus code, I think they called it, and that contained the drivers for the hard drive controller that's unique to this machine. So that got me thinking, maybe I could just find disk images of the Super Kickstart disk, and I could just make one with my grease weasel, and then we could boot the computer. There were some links in some old posts that supposedly had those images there, but those links don't work anymore, and yeah, I just couldn't find them. But while digging around looking for those Super Kickstart disk images, I found something really interesting. In the machine right now, I have those original ROMs, the one that say ROM 1 or ROM 0 V5. If we turn on the machine, I think we should end up at the boot menu. Okay, there it is. So this is where we would put the Super Kickstart disk into an attached floppy drive, and say we click this. Now insert the Super Kickstart disk in DF0. Well, this is where I don't have that disk. There's not really too much I could do. But if I reset this machine, someone mentioned in one of those posts about the Super Kickstart that apparently you can bypass this boot menu and get to a boot screen for regular Kickstart or whatever version is actually here. Now you would think you could just hit the cancel button and that might do it. No, that just resets the machine. We're going to end up right back at the boot menu. And you know, when we click around to the screen on various areas of the screen here, I'm clicking the mouse button, nothing really happens. Well, apparently if you go to the top left corner and you click, that goes to this boot screen. And I tested this off camera before starting this, and look, there it is. 1.4 beta EXP, do not redistribute. Whoa, okay, so this is the first sign of life that we've actually seen on this machine beyond like, yeah, frozen screen or the yellow screen, or of course, I had the Amiga diagrams working as well. But I've never seen it actually get to a point where I was gonna try to load Kickstart. This is wild to me, absolutely wild. So theoretically, if I plug in a floppy drive, maybe we can boot Workbench? Okay, so this is a floppy drive that was with the computer when I got it. Looks like it has a 1990 date on there, and it says dead. Not sure what's going on with that, but I think I might know what might have happened to this. So when you plug in the power cable onto these floppy drives, this is a Berg connector for power. Well, one of the issues is you can plug this cable in both ways on this drive, and if someone did that, then they would have put 12 volts into the floppy drive, you know, into the 5-volt part of the floppy drive, and that would potentially destroy it. Yeah, see, like that actually goes on the wrong way, and that would definitely damage this floppy drive. So I don't know for sure if that's actually happened, but what I did is I just put in a little adapter here, a Molex to Berg adapter, and this can only go on one way. So that is the correct way. So let's get the floppy drive cable connected up to this drive, and let's see if this drive has, well, any signs of life. Pin 1 is right there, so that's the direction the stripe goes towards. And for booting this machine, I have a copy of Amiga test kit. Well, let's just pop this in. We'll know pretty quickly if the drive is even trying to work, because I think that Super Kickstart boot ROM thing that's on here is going to try to access the floppy drive. So if it does nothing, then yeah, this drive is dead, and someone probably put the power cable on the wrong way. Okay, the drive did nothing so far. Let's try clicking floppy. Yeah, no activity out of the floppy drive whatsoever. All right, so I have another floppy drive. I wrote good, it's from an A1010, I think it is. So this is not the right floppy drive to be mounted inside the Amiga 3000, so I can't use this, but it's still a double-sided disk drive. Should totally work on here, plugged into this cable. I just had a thought on the other drive. So drive select 0, this is how Amiga drives should be configured since they have the twist in the cable. And the dead floppy drive, there are the drive select jumpers. So drive select 0. Okay, yeah, it's already set to drive select 0. So those two pins right there are drive select 0, and that's where the jumper is. Okay, so that's not the problem. And this is just a random disk in there, but if I click floppy, the head's actually moving. I can feel it moving as it's trying to look for that disk. So let's get this random black disk out of here, and I'll put the Amiga test kit disk in here. Okay, so right now, if I click floppy, the head's making a clicky noise, but that disk is obviously not a Super Kickstart disk, so that's not going to work. But theoretically, go to the top corner, click the button. It's freaking loading. It loaded! It's working. What? I don't even get it. 5 megs total memory? Yes, that's correct. So we've loaded an Amiga program off a disk on this computer that just refuses to work with the regular Kickstart ROMs on here. Oh, I'm just beside myself here. And I swear earlier when I had the other ROMs in here, we were getting the red screen as well. Like red screen. The yellow screen of death was coming up, and it wasn't even doing that originally, but now it seems to be stuck doing that all the time. And here it is, just freaking working. Oh, wow. This is wild. Okay, so it's gone through an entire RAM test and it worked. I've hooked up the audio cable here. So let's, I don't know, let's go back up and, well, I know the keyboard works. Yeah, it's working fine. Floppy drive obviously works because we just booted this thing. Mouse is working, so we don't really need to do much testing there. Audio. The audio works, and the audio worked in the diagnostic ROM as well. So I'm not surprised about this. Low pass filter is working properly. Okay, so that works. Video, yep. If you've ever used the test kit, this is how it looks. And then let's see, battery backed up clock. No clock detected. Yeah, shocking. Of course, it's not on there. Precision timers. Looks like everything is working correctly. Cool. I don't think I could do the peripheral port test. This may damage hardware. Okay, I'm not going to touch that one. And it does think this is a 68030. It says it's ECS, it says it's NTSC, and it says 60 Hertz, which is all correct. So question is, if I push help to reboot, will it just go back to the boot menu, which I assume it will. Yes. And let's click this button up here, and let's try to boot into Workbench. Okay, I have a copy of Workbench 2.05. I mean, I have no idea if this is actually going to work with this old 1.4 ROM. I mean, it's doing something right now. It's trying to boot. Please insert the disk file libs. Okay, cancel forever. I mean, I just don't get it. Workbench 2 is in the drive. What are you complaining about? Weird. I'm just going to try a few other disks here and see if any of these boot. Oddly enough, this was a Workbench 3 boot disk, and it gives us that. That's odd. Okay, so this is a game. I think this is Chaos Engine. I assume games don't need any kind of Workbench stuff. They just need a little bit of Kickstart to get started, and they probably work. So maybe this will be a games machine. Yeah, look, it's running. It's so funny. I'm able to like run a game and yet not run like Workbench. Yeah. We got music. Chaos Engine is running. All right, let's take stock for a second. So Kickstart 1.4 ROMs, the original Amiga 3000 ROMs, seem to work fine in this computer. Although I don't have the Super Kickstart disk, so I can't really test booting into Kickstart 2.04. I would be able to if I could get one of those disk images and make the disk. I was able to boot into Chaos Engine without issue, and I was able to boot the Amiga test kit fine as well. It's just like Workbench doesn't load, and I did try Workbench 1.3. That didn't work either. Now the question is, and I can hear people saying this, that maybe all the trouble I was having with the other ROMs were happening because I didn't have the floppy drive connected. I don't think that's the case. I mean, these ROMs, the 1.4 ROMs, work fine without the floppy drive connected. They just, you know, you obviously can't boot software. But the fact is, it goes to the boot menu without issue. But if I put back in the 2.04 ROMs, well, let's just give it a try. I assume we're going to go back to just the gray screen, or we're going to go back to the yellow screen, which seems to really be the affliction of this board. Yeah, I don't know. And the ROMs that were in this machine have the exact same part number, they just have -03 versus the -02. So they seem like these are the right ROMs for this computer. All right, there we go. The ROMs are in. I have the floppy drive connected. I'm going to put the test kit disk in there since we know this definitely boots no matter what. So I'll pop that in the floppy drive, and I guess let's see what happens. I am fully expecting this not to work. So yellow screen or just gray screen. Yeah, okay, we're getting the yellow screen now. Why? The hardware was running perfectly a second ago. We're running games without any issue. Test kit was working. The test ROMs work. All right, I think I need to take a different tactic here. I'm going to go back to Kickstart 1.4 that was actually working in this machine. And I'm going to try to play around with loading some more software off of the floppy disk drive, which is still hooked up here. And I say that because that was literally the best hope of actually getting this thing to work, because this was actually showing signs of life. All right, is this thing still going to work? Same way it was working before? Yes? Yes? Maybe? The disk is loading? Good. There we are. Same spot we were at before. Now, huge thank you to a wonderful viewer who pointed me towards the Super Kickstart ADF files that I needed. So Super Kickstart 2.04, same version that was in the chips that were on this machine, but it's an ADF file. So theoretically, it should work with this Kickstart ROM set that I have in here right now, which is asking for a floppy disk. So the file's downloaded right here, Kickstart 204 ADF, and I'm gonna write this to an Amiga disk image. So we're just gonna drop it onto there. This is gonna use my grease weasel to do it. And I do have a disk in there. There we go, the disk is writing. Perfect, this double density disk is in the disk drive in my lab PC here. And let's see if this is actually gonna boot. I mean, I'm half expecting this to start loading, and then I guess it restarts the computer and then uses the MMU to map the RAM-based Kickstart into the ROM location. And then it's gonna just do the same thing where you get the yellow screen. That's my assumption, at least. Okay, there is the Super Kickstart disk is done. I can take this, I think, Amiga test kit out of there. Let's pop this in the drive and see what happens exactly. All right, well, this is supposed to be Kickstart 2.x or whatever. Hey, that's more than I've ever seen. So yeah, I assume it's gonna load off the disk and then reboot the computer. That's what I think is gonna happen, at least. And if there's nothing wrong with the code on the original ROMs that were on this board, then we're gonna get the yellow screen even with this software-based Kickstart. Which would imply that Kickstart's trying to talk to some component on the machine. Here we go. Yeah, yellow screen! Okay. Okay. So that tells us that Kickstart is trying to talk to some component on the motherboard that the Amiga diagnostic does not test, and that also the Kickstart ROMs that are on here now, the 1.4, also does not test. But when this Kickstart goes to talk to it, it fails. But what component is that? I am no closer to knowing the answer to that question. No closer at all. Okay, one thing I had read is that the Super Kickstart disk actually contains 1.3 and 2.x on it. And let's just see if that's the case here. I mean, it's loading like it's doing something. Now, there were two files that were on that website. One was a 2.00, and then there was 2.04. So my assumption is both of those have both Kickstarts on them. Okay, 1.3. I guess 1.3 just hangs. Oh, no, it doesn't hang. So I took the disk out. Oh, look, it's, I mean, what? Let me go grab I have a workbench disk right here on the ground, 1.3 workbench, an original one. Let's pop this in. Battery backed up clock, not found. Yeah, I wonder why, because it's literally not on the board. So I tried booting Kickstart or Workbench 1.3 earlier using the Kickstart 1.4 ROM, and it wasn't able to, which is weird because if you're using the 2.0 ROMs and you put Workbench 1.3 disk in there, it works, it's fine. But there's something going on with the 1.4 ROMs that are on here. I guess they're just not designed to actually run a workbench. The mystery freaking deepens. Now, here's my question. If I hit Control Amiga, let's reboot, will it stay in Workbench 1.3? I don't know. Yes, it looks like it does. So the soft Kickstart stays in memory. I think that's why our memory count was low as well. I think 256K of our RAM was taken up by the Kickstart. Okay, so watch. I'm going to turn the machine off at this point, and you will see that when I power back on, it definitely will not boot into Workbench just like we had there. It's going to come up with that boot screen again, where it's going to want me to insert this, yep, soft Kickstart disk. I'm still no closer to understanding what's going on with Kickstart 2 and I guess 3, because we put those ROMs in and that was giving us the screen as well. What's causing the yellow screen when the whole computer just kind of works on its own? I don't know, but I just popped out the disk. Let me pop in the Workbench disk. Yeah, like I was just saying, I don't know why the machine is giving us the yellow screen with the 1 or the 2.x ROM, but 1.3 works without a problem. I am going to try the Super Kickstart 2.x one more time. I just want to see the yellow screen of death happen, just to confirm that it's definitely still working, even though everything's working fine with Kickstart 1.3. Here it comes. Take the disk out, and there's our yellow screen. And it just goes to a black screen afterwards. It doesn't even try to do the rebooting with the actual ROMs in there. It just sort of continually reboots. So if I hit Control Amiga, does reboot the computer, because I think that's a hardware reset coming from the keyboard, and there it is, yellow screen. I assume it's gonna go black. Oh, now it's actually stuck in the boot loop as well. So identical to the ROMs now. Different than it was originally, but identical to the ROMs. And yet, well, you could see what's happening. I don't need to kind of rehash it once again. All right, as you can see, I've changed clothes. It's the next day, and I've had time to kind of organize my thoughts. I've taken some notes, and I also edited up all the footage I've had for part 2, so I could just kind of see what I've skipped over, what I need to explain better, what I need to cover, etc., etc. Right, so what do we know that actually works right now? So Kickstart 1.4, these are these ROMs I found in my stash of chips, that has no trouble booting the Amiga test kit floppy disk directly. And when that boots up, everything passes, all the diagnostics pass, along with fast RAM. So it's able to see the additional fast RAM, which is 4 megabytes on this machine, and the 1 megabyte of chip memory. Now with the Amiga 3000, and I should have talked about this a little bit more, it's really a fully backwards compatible machine with the Amiga 2000 and the 500. Really, Commodore just took the original chipset and they grafted on these additional features. And specifically, it's the 32-bit DMA SCSI controller this machine has, and it's the 32-bit fast RAM up to 16 megabytes this computer has. And of course, it's a 68030 processor, 25 megahertz or 16, and a floating point unit. Now, as evidenced by the fact that there are lots of accelerators for the older Amigas, the original chipset and all the ROM code like Kickstart 1.3 is fully compatible running on a 32-bit version of the processor. I mean, all 68,000 chips are 32-bit. It's just externally only the 6820 and beyond actually are externally 32-bit. Otherwise, it's externally 16 bits. And then the memory map on the 68,000 only allows up to 16 megabytes of RAM, even though internally, I think it can address the full 32 bits of 4 gigabytes of RAM, but there's only address lines for 16 megabytes. So with the 68020 or 68030 or anything above that, you have all of the 32-bit addressing available to you, so the full 4 gigabytes of RAM, and then you also have, of course, the 32-bit external data path, so that means you get faster access to your RAM or any other 32-bit device. The original Amiga chipset, though, is 16 bits, so when 68030 on this machine is talking to the original chipset, it's doing so at a 16-bit way, so you're not getting any real performance improvement. Although, from my understanding, there are some speed-ups with the 32-bit access to the 32-bit chip RAM that's on this machine. I guess it interleaves access between the chip memory, the CPU, and the Amiga chipset itself, so that presents itself with a speed-up. But that's transparent, just like the Amber flicker fixer that's on this machine. The OS, the software, the Kickstart ROMs, all that stuff, can't really see any of that stuff. It just sort of happens at a hardware level. Really, the only thing that's new that isn't transparent is the SCSI controller and the 32-bit fast RAM. Now, when we booted up the Amiga test kit using Kickstart 1.4, that's this pre-released beta version of the Kickstart here, it was able to see all the memory. We saw 5 megabytes. That meant the fast memory was working. And on this machine, this is the fast memory right here, these zip ICs, and this chip here is called RAMZ, and this is what makes the 32-bit access to this fast RAM possible. If I remove this chip from the board, I think the computer should still work. It's just only going to be able to see this memory over here, which is the chip memory, and this stuff just won't work at all. I have a feeling that at least running Amiga 500 and 2000 software that doesn't expect to find fast RAM, it's not really going to have any kind of problem. Of course, if we're running any kind of Kickstart ROMs that know this is an Amiga 3000 and they're going to look for RAMZ and this additional fast RAM, well, that potentially could be an issue. Now for the SCSI controller, and that's the SCSI controller IC, Commodore added this chip here, which I think is called DMAC or Super DMAC, something like that. And this is the DMA controller that allows this 8-bit SCSI IC to interface to the 32-bit bus. Now this chip here is called Gary, and Gary chip on the Amiga in the 3000, but even on the 500 and the 2000, this is a chip to kind of consolidate a whole bunch of discrete TTL logic, select logic, and stuff like that into a single IC. Pretty sure on the 500 and the 2000, it's a different package. It's like 40 or 48 pins. And this is a version that's been enhanced to support the additional features on the 3000. Specifically, this chip is now selecting the SCSI controller and it's selecting RAMZ for the additional RAM. I think there's some other functions that this adds to support the 32-bit processor that the original Gary didn't need to worry about because that was a 16-bit system. So from what we've been able to kind of ascertain so far, when Kickstart 2.04, either the ROMs that I had in the board or the soft kick or super Kickstart version, that's a version that loads it into RAM and then executes, that seems to give us this yellow screen because it's probably trying to talk to some piece of hardware on here, some of the new hardware that's not working. Now, when we think about the new peripherals that are on this machine, we can rule out that some are working and some aren't. We know that RAMZ and the fast RAM is working. Now, from my understanding, the normal Kickstart 1.3 and 2.04, the ones from the Amiga 500 and the Amiga 2000, they wouldn't expose that additional fast RAM. They don't know about it. So if you booted those systems, all we would be seeing is the Amiga 500 and 2000 compatibility mode, which would result in just chip memory and then all the other regular Amiga functions working. We also wouldn't have any SCSI controller activity, but we haven't been able to test that anyway so far. Now, when I use the Super Kickstart disk with this Kickstart 1.4 ROM to load Kickstart 1.3, and then we booted Workbench 1.3, it did show the additional memory. So that means that that Super Kickstart disk, or maybe the Kickstart 1.4 ROMs, loads a special version of Kickstart 1.3 that's probably on that Super Kickstart disk that has additional code added to it to enable, well, enable the fast RAM at the minimum. We know that's working. And maybe it enables the SCSI controller. Hard to say because it's not, we have a SCSI disk connected up to the system. Now, I'm assuming that Kickstart 2.04, the version for the Amiga 3000, also has this extra code. I think I've seen it referred to as bonus code. And this is what enables the RAMZ fast RAM along with the SCSI controller stuff. It likely also enables the additional caching inside the 68030 processor, which brings a big speed improvement. I think with the 68030, when you first power it up, the caches are disabled for compatibility reasons, and they have to actually be turned on for the additional speed up you're going to get. On the Amiga 2000, if you have an accelerator, a lot of times you need to have a special driver that you would load into your hard drive, and as it boots up, it would enable the caches, and it would do some other stuff to speed up the machine. One of the main things that would be a big speed up on the Amiga 500 and 2000 if you're running an accelerator is to take the Kickstart ROM and copy it into fast RAM. Now, the thing about the Kickstart ROM is it's designed to run from a specific location in memory, right? You can't just move it around arbitrarily. Well, when you have a 68030 processor like on this machine, there's a memory management unit, and the memory management unit allows all sorts of shenanigans to happen with the memory, specifically virtual memory and stuff like that. But what you can do is you can load something like the Kickstart ROM into RAM, and then you could use the MMU to remap that chunk of memory to act as if it is in the space where the ROM is. So if anything goes and tries to talk to the ROM, instead of the processor going to the address lines where the ROM is and selecting the actual physical ROM chips, it's actually going into RAM. And I've definitely figured out that when you use this Super Kickstart function of the Kickstart 1.4, when it's loading Kickstart 1.3 or 2.04, which we can't really make work yet, but I'm assuming it's going to work that way, what it does is it loads those into RAM, and it uses the MMU to kind of remap them into the ROM space, reboots the machine, and then from as far as the Kickstart ROM and any kind of software you load knows, well, you have the actual Kickstart ROMs physically in the motherboard. Even though they're not, it's running from RAM. Now you lose that chunk of fast RAM to that remapping. You're going to lose like 256K for Workbench or Kickstart 1.3. I think it's 512K for Kickstart 2.04 or any of the later ROMs. But it's a really worthwhile trade-off because, of course, you get a massive speed up on a machine like this that has 32-bit fast RAM versus the very slow ROM chip access. And because Amiga runs a lot of its operating system from ROM, that speed up is dramatic when you kind of do this copy. Now, I wouldn't be surprised if the actual Kickstart 2.04 ROMs that are on this machine, these two that aren't working, I have a feeling when these are working properly, probably something that they do themselves is they copy themselves into fast RAM and then they use the MMU to remap the RAM into the ROM space. So basically the same thing as the Super Kickstart is doing, it's just doing it physically in the chips. That would mean literally once the computer's booted, you could probably just remove these chips from the motherboard if you know, without powering it off, and the computer will continue to work. It's no longer accessing these chips anymore. So I have a feeling that's what's going on here, and that's definitely what's going on with the Super Kickstart. So I think that the first thing I should do is I should just validate a couple of the hypotheses I have about how it's remapping the memory and stuff like that, just so we can get a better understanding, and then I have some ideas of what we can do next to try to figure out what's wrong with this computer. So let's do a few tests. I have Amiga sysinfo 4.3, which should be bootable, and maybe this is bootable with Kickstart 1.4 directly. And then I also have the Super Kick 1.3 and 2.04 disk for further testing. Let's put this in the drive, and we'll click in the top left corner. Let's just see if I can actually boot this. And this utility is good because it'll allow us to see the status of the caches, and we'll also be able to see what the memory map is, for the most part at least. Okay, so it loads. Awesome. Okay, we're getting an error about 6840. I don't know what that's all about. Whatever. Okay, so there's the Kickstart ROM. Now, this is at the standard location where Kickstart is on all Amigas. I mean, even the Amiga 1000. It was located at FF00, and I think it goes down or up. I can't remember which direction it goes. I think it goes down, so it's like all the way down to FD or FE or something like that. And it shows it as 512K for this weird version, 3312.20. That's a nonsensical version number. Now, obviously, we have 32-bit RAM working right now because all these various things are loaded into the 32-bit RAM, except there's our chip memory all the way at the beginning of the address space. And if we go to memory, this will actually show us the memory. So this is going through RAMZ, and this is obviously initialized. So Kickstart 1.4 initializes the RAM and exposes it to whatever the booting OS or disk is. Now, the funny thing is here is we can see that the amount of free memory in the fast RAM is almost the entire megabyte, 4 megabytes. That means that that caching of the Kickstart ROM is not happening here. I have a hypothesis that if we boot into, say, one of the other Kickstarts like 1.3, the one that's working on here using the Super Kick, we're going to be missing some of this free memory here because it's going to be used for remapping the Kickstart into RAM. Now, of course, the other chunk of memory we have is, there it is. That's our 1 megabyte of chip memory. And if we had 2 megabytes, it would just kind of be above that. It would go all the way to 1 FFFFF. Other things we can see in here that sort of tell us that this is not using the MMU to remap anything is it says MMU not in use. Pretty sure that would say in use if it were being used to remap the memory or the Kickstart ROM, like I said. Also, I've learned that on the Amiga 3000, the SCSI controller on here is not auto-configure. Most Zorro cards, like if you plug a SCSI controller into an Amiga 2000, it is auto-configure. That means there's a ROM on there that allows the OS to kind of configure it, load or driver, stuff like that. But since the SCSI controller on the 3000 is not auto-configure, it doesn't show up as a Zorro card. That means that the Kickstart itself has to do the initialization, which is exactly what happens with the original Kickstart 2.04 ROMs that were in here. That should have been the case at least. Okay, next thing I want to do is I want to try Super Kick, and I'm going to load Kickstart 1.3 off Super Kick because this is the one that works. And let's see how it looks inside of sysinfo when it comes to the MMU and the caching and stuff like that. So we're going to run 1.3. All right, so right off the bat, we can tell we're running in Kickstart 1.3. The font looks different. And there's that same error about the 68040 installation alert. I definitely don't have 68040. Exec does not reflect your hardware correctly. Do you want it changed so that it does? Okay, sure. Okay, so here we go. Kickstart. It's loaded it at the normal Kickstart location, but it is 34.5, which is 1.3. We do have working 32-bit fast RAM. So some of this stuff is in chip RAM. I think that's 1.3's limitation is certain functions have to live in chip RAM, which is slower. And it was later versions of Kickstart that fixed that, where more things could actually exist in fast RAM. But we obviously have working fast RAM because we have a bunch of stuff that's in it. So here's our fast memory, but notice it only has 3.5 megabytes now. So what has happened with the Super Kick is it reserved 512K of the fast RAM for Kickstart ROMs. So even though I'm running 1.3 right now, which only uses 256K, it's still carved out 512K from our fast memory for the MMU to remap it. So there's our little telltale sign that it's definitely remapping the Kickstart ROM and loading it into RAM, and the system reboots and is able to execute from that cached copy as if it is the actual ROM. So that's a good little telltale sign. And then chip memory, same exact thing. We have a little bit less free because Workbench or Kickstart 1.3 is using more of it, but yeah, same total size. And as for the rest of this, using Super Kick 1.3, we have no auto config board. I think drives looks the same. Yep, there's no way to click the SCSI. I don't know if that's just because it doesn't work in 1.3 or it's because I don't have a SCSI drive hooked up. That's exactly how it looked when I was loading Kickstart 1.4 as well. Right, so we learned some information here. We know for sure that the CPU caches are working. We know the MMU is working. We know the fast RAM is working, so RAMZ is good. All the memory is available. It's able to remap the ROM into it and work without fail. We have validated that is absolutely the case. So now that brings us back to the question of Kickstart 2.04. Why is it giving us that yellow screen when we boot, either with the physical ROM chips or the Super Kickstart soft version of it, where it's loading into RAM? They both do exactly the same thing, which tells us that it's not the physical ROM chips that are the problem. It's not like a failed ROM because this disk is doing it too. So there's definitely something about the way that Kickstart 2.04 initializes the hardware for the Amiga 3000 that is different than Kickstart 1.3 and different than Kickstart 1.4, because those seem to have no trouble initializing the hardware. It's definitely 2.04 and most likely 3.04 as well, which are these ROM chips I tried in part 1, and those don't work either. That just gives us, it goes from a black screen to a yellow screen, which we can assume is the same error that's happening. Okay, so now we're going to get into the meat and potatoes of trying to figure out what is going wrong with this computer. Now, there's a few things that we have figured out here. This Super Kickstart function, where we are able to load a Kickstart off a floppy disk and make the computer reboot and use it, maybe we can use it to our advantage to load different code onto this machine to see exactly, well, maybe we can get more signs of life out of this thing using that extra code. It turns out that there's a utility that was made in the 90s called Make SuperDisk, and it was written by Olaf Barthel. This utility allows you to take any Kickstart ROM, not just the 2.04 or 1.3, and make a super Kickstart disk that works with this ROM to allow you to boot your Amiga 3000 with different ROMs. I think the main idea for this utility was that you could make Kickstart disks for newer Kickstarts, like 3.1 or 3.0, the stuff that came out after the fact. And I think Commodore wanted you to buy replacement ROM chips, but you know, the community back in the day, people were like, hey, I already have these ROMs on here, allow me to like load different Kickstarts off of floppy. Why can't I just load the 3.0 or 3.1 and have it actually work? So I reached out to the viewer who was helping me so much with all that AGFA stuff that I've been working on the last few videos. And I said, hey, can we make a super Kickstart disk that's got the 2.04 Kickstart from the Amiga 2000? Not the Amiga 3000 version, the one that's actually on these chips, but the one for the Amiga 2000. Because as I was just saying, the Amiga 3000 is backwards compatible with the 2000 and the 500. Therefore, those Kickstarts should work. The idea is that if there's something in the Amiga 3000 version of the Kickstart that's trying to talk to some of the Amiga 3000 specific stuff that's crashing this machine, then potentially loading the version for the 500 and the 2000, which won't talk to those bits of hardware, would allow it to boot. This is totally untested. I don't know if this is going to work, but my hunch is that it will work, but we won't have the fast RAM and we won't have any SCSI. All right, so this is Kickstart 2.04 for the Amiga 500 and 2000 as a super Kickstart disk. Let's give this a try. This should just load and then give us the insert disk image, like the regular Kickstart 2.04 thing that we've never actually seen because it's always crashing on this machine. And then if I boot the system off of Workbench 2.05 disk, that should result in a system that's working. We just don't have access to the fast memory or the SCSI controller, the two special peripherals on the machine. Here we go, rebooting. Okay, there we go. It worked. Look at that. So I'm just looking for my Workbench 2.05 disk. Here it is. So we'll just stick this in. So we're testing a few things. We're testing that the Amiga 3000 is fully backwards compatible with the 500 and 2000. So even the original Kickstart ROMs from those machines work on this machine. So theoretically, I could make, split it up into two chips and put one of the original ROMs on this machine and it would run. We would just lack those additional drivers. Okay, well, clearly it's not fully working. Where exactly, where are the icons and everything? Well, that's not good. Interesting. So my hypothesis was only sort of correct. I just rebooted the computer. Let's see if it boots up better this time. At least it's not giving us the yellow screen of death. All right, same exact problem. I'm gonna try loading sysinfo 4.3. It's weird because I put the disk in there and it like read it, but yet where's the backdrop? It's like it's somehow like rendering to something else, like a different monitor. It's very weird. Anyhow, we'll reboot. Let's see if this works. I guess my hypothesis of being able to use the Amiga 500 code on this machine kind of works, but not fully. All right, and this didn't work either. That computer actually froze. Let's try that one more time. This is a sysinfo disk that we know works on this machine. But there we go, software failure, okay. I wonder if there's something to do with the memory management unit. And because this software, especially like sysinfo, maybe is trying to manipulate the MMU or the caches or something like that. And obviously the Amiga 500 and 2000 version of Kickstart is not expecting that hardware to even exist since it's designed for a 68,000. That's somehow causing an issue. Although it's very strange what's happening in the Workbench disk itself. We get it loading just without the backdrop and no icons. That's a weird behavior. But we have learned one thing. We've learned that Kickstart 2.04 for the 500 does mostly seem to work. It doesn't give us the yellow screen. So it definitely tells us that whatever's wrong with this motherboard has to do with the Amiga 3000 specific hardware. And of course, weirdly enough, when we use SuperKick 1.3, well, that works. And we use Kickstart 1.4, and that works. So it's really something that Kickstart 2.04 for the 3000 and beyond tries to do with this hardware that's giving us that crash. But what exactly is that crash? To reiterate what I had found in part 1 when I tried to search what the yellow screen means on Kickstart 2.04 or later, Well, there's really not much information here. It does say yellow, an unexpected processor exception before the appropriate system failure message was prepared, or an attempt to access a RAM address where no RAM exists. And if you think back to part one, the initial problem this machine has is it was sticking or getting stuck at the light gray, which is software is coming in and seems okay. But now we get dark gray, light gray for a split second, and then it goes right to yellow, which is this unexpected processor exception. And what it's talking about here is the system failure message. That would be like the guru meditation or the later software failure message that pops up at the top of the screen. That's the exception handler that pops up to give you a little bit of information about exactly what has crashed. Generally, as an end user, it's not particularly helpful, but that's something to go off of. But this yellow screen is, well, nothing to go off of. We just have no idea what it's talking about. If it's possible to make these super Kickstart disks to load like an Amiga 500 version of Kickstart, what happens if we try to load other code? What if we try to port AGFA monitor from the AGFA CompuGraphic 9000 PS to run on the Amiga? Because that will give me a monitor, a machine language monitor on the serial port that potentially allows me to poke around, read memory, write to memory, do stuff. That's possible. And maybe with these super Kickstart disks, it could save me from having to burn a bunch of physical EEPROMs, and I can just load it off a floppy disk and reboot the system, and then we got to go from there. So earlier, and I didn't really show this, but when I was running the Amiga ROMs on here, I did plug this no modem adapter along with this adapter into my PC so I could see the serial port activity, and it was working. It just mirrors what you see on screen with the menus and stuff over this port. So I'm already ready to go with the Amiga serial port if we're gonna try to run the AGFA monitor on this machine. All that's required is the super Kickstart disk with the AGFA mon on it, and that's exactly what this is. All right, let's give this a try and see what happens. It's untested on real hardware, so hopefully this actually works. And this window right here, this is PuTTY on COM2, 900 bits per second, 8N1. And if we hit this to load Super Kickstart 2.x, which is what the AGFA monitor is like acting like, it sort of replaced the 2.x, the 2.04 image on this floppy. And the Amiga below my head here should reboot, and then if all works, we're gonna get a monitor prompt. And I will not be using the Amiga keyboard. Here we go. There it is, Amiga Mon. Adrian Black style monitor for the A3000. Port of AGFA monitor with EH Basic 3.4 or 5.4. And there you go, super Kickstart compatible, but it could also easily be flashed into actual ROM chips right on the board. And yes, it's freaking working. So this is the memory of the Amiga right now. We're looking at it. Now, luckily, this is a port of the 68020 version that came from the AGFA CompuGraphic 9000, because there were two versions of this, one for 68000 from the original I.O. board from the AGFA. That was just a Motorola 68000, so it didn't support the full 32-bit addresses, but this version does support the full 32-bit addresses. We should have BASIC on here. Yeah, there's actual BASIC running. I mean, we're not running any OS on this computer right now, right? This is bare metal running on the Amiga. It's not using any of course, the Amiga chipset and stuff like that, but it is actually running on this machine, and it's very similar code to what was on the AGFA. The main difference is, of course, the location of the Kickstart ROM is different than where it was mapped on the AGFA, and then the chip memory on this, once the system boots up, exists at the beginning of the memory map. So we'll just do a little program here. Does this work? Yes, it does. We actually have it working. Now, I am curious to see if the 32-bit RAM is working. Obviously, it's kind of initialized, right? Because the Kickstart ROM is loaded into it right now, and then the MMU is remapping it. So is the rest of it available for us to use? And the memory map explains to us that any fast RAM that's on the system actually grows down from this address. So if you have 1 megabyte of RAM, it's up at that top. But if you add the full 16 megabytes, then it will take this entire space here, all the way from this 10000000. So with 4 megabytes of RAM, this is the number of bytes that we actually have. So 400000. And if we take the top of memory space, which is this address, and we subtract the amount for 4 megabytes, so theoretically 7C and all zeros is the beginning of our RAM. Now that's it. Is this in use by AGFA monitor right now? Maybe, but those patterns sure look to be repeating, don't they? Well, let's just try writing to this RAM. I'm pretty sure this is actually going to work. So we do that with the E command. And I'm just going to write something that's obvious. And now if we take a look at this RAM, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay, so fast RAM is totally working, which is cool and good to know. But of course, I already knew that the fast RAM was working on this machine. We've seen it work a bunch of times before. That is clearly not our problem. Our problem clearly exists outside of the fast RAM. It has to do with, well, the other parts of the Amiga 3000 that are special. Well, what else is there? Well, going back to the memory map, I don't think there's anything else that's really special because all of this stuff is just normal Amiga 2500 stuff, which seems to work. Then we have our 32-bit RAM, which seems to work. And then we have 32-bit expansion RAM, which, well, who knows what that actually does. Somewhere in this memory map has to be our SCSI controller. And it's not listed here in the service manual, which is kind of annoying, to be honest, but it's got to be in here. The other thing is I am curious is if we try to write to something outside of our memory map, Agfamonitor does have an exception handler. Let's try to access this memory address right here, since we know that that doesn't physically exist on this machine. All of this RAM here, even though the stuff that's not on the motherboard, I have a feeling that RAMZ probably, doesn't generate a bus error or anything for that RAM. It probably allows you to access even the RAM that doesn't exist, which is how the RAM check and size routine is working without just crashing immediately. But anything outside of that that doesn't exist, like this, that should generate an exception, which theoretically could be happening when Kickstart 2.04 is loading. So let's do a D command and we'll do that memory address that doesn't exist. Oh, that didn't crash. That's shocking. Why don't we try this address right here? I don't really know the behavior of the Amiga. Well, it's allowing us to access memory locations that just completely do not exist. Oh, I see what's happening. It's dropping a 0. That has one less 0 than it should be. If we add one more, that's probably going to just crash. Yes, it does. Okay. I need to be careful about the number of zeros that are on here. All right, let's do this again now that I have my number of zeros correct. So 32-bit expansion RAM that doesn't physically exist in its computer. It does work. So all that memory space is working without a bus error, but I think as soon as we go outside of that, that would be up into this range here, this other space, it'll immediately crash. And there it goes. So it listed the first byte here, which is at the very top there, all Fs, and then it went up to 1 and all zeros, and that's where it crashed. Anyhow, I just wanted to kind of get a feel for what the memory map on this thing really looks like. And I need to try to figure out where the SCSI controller actually is on this machine. It's got to exist somewhere in this computer, right? Maybe it's inside of this area, unused on this machine. Does it say unused? So I guess it's not that. So maybe it's inside one of these other areas as well, down in the 24-bit memory address space. Okay, so I decided to use WinUAE since the best Amiga emulator I know about. And I set this up to be like an Amiga 3000. The cool thing about this is I can test various ROMs and stuff in it, but it has a hardware info button right here. Whoops. And there it is. There's the SCSI controller. Okay, A3000 SCSI DD0000. Very misleading of Commodore to list the real-time clock as DC00 all the way through DDFF, where the reality is DD0000 is the SCSI controller. But I'm kind of curious to accessing any of these memory locations, like say this unused one. Will that result in a crash in Agfamonitor here? Nope, that one worked. How about the DD one then, which is supposed to be our SCSI controller? Nope, that seemed to work as well. So I spoke to my viewer who did a little bit of looking inside of the Kickstart ROM to kind of look at what's happening with the SCSI registers during the initialization, if that's the problem we're having with this machine. And this is some of the stuff that we might need to take a look at. So we have the DMAC chip ID register. We have the SCSI address register, and that's the actual SCSI controller chip itself, this one here, and that being DMAC. And then we have the SCSI data transfer request. Well, if we can take a look at all of these various memory locations and we don't get a bus error, that kind of tells us that the bus error that's happening when Kickstart tries to load, well, doesn't seem like it's coming from the SCSI controller. Well, unfortunately, I did it right there. We looked at all the registers there for the SCSI controller, and there was no bus error. In fact, it was DD0020, that was one of them, and then DD0040 was the other one. Well, we did not have an error reading any of these locations. There's no bus error. And let's read more of this memory space. I bet you it just loops. Yep, it's looping over and over again. That's just typical, but no bus errors. Now, I wonder if writing to these locations, maybe that causes a bus error. So let's just try writing to one of these, and that didn't do anything wrong. And let's try writing to this other register. I mean, it's kind of rude what I'm doing here, but just testing, right? That didn't do anything bad. And then there was one more register to write to. I don't know, that doesn't seem to cause any problems either. Now we're doing 8-bit writes, not 16-bit or 32-bit writes to these registers. Maybe that's somehow related to this fault. I don't know. But this kind of tells us that this SCSI controller at least is readable and writable without any issues. Now going back to the memory map here, we obviously have working I/O space because our serial port works, and mouse and keyboard and all that stuff is working perfectly. Auto config expansion space, this has to do with fast memory on the 16-bit versions of the Amiga. None of that exists on here, so I don't know what would happen if we try to read this. Maybe we'll get a bus error. Nope, we don't get a bus error, it just works. Let's look at this C space, see if this works. Okay, well that caused the system to crash. That's fine, I'll just reboot it. Good, it's still rebooting. So that might be fine, that might be normal. This magic memory, I don't know what that means exactly. We already know that DA worked. I think I tested that earlier. Let's look at DC. That's the real-time clock that doesn't exist, so that doesn't do anything. Custom chip registers, we know that stuff works, right? Because like the OS boots, I was able to play Chaos Engine, so clearly that's all working. Let's try this, unused memory. That doesn't create a bus error. Let's try this next thing, E8, that's the auto config. That's fine. And more auto config up here, totally fine. And then of course we already know that the ROM space is working because the memory management unit is remapping into it. So far we have zero conclusive evidence from running AGFA monitor that there's anything wrong with this computer, but we obviously have a fault here. It's just not exposed by poking around in the memory right now. The only conclusive thing we have is that a bus error is generated when we try to access anything in this other RAM expansion space. Everything else doesn't generate a bus error, which I'm assuming is just normal behavior for the system. I was really hoping that we would kind of get to the bottom of exactly where this exception was coming from. And I was really thinking it had to have been the SCSI controller, since we know most every other thing on this board is working perfectly. It's just, that's the one thing we haven't tested. But accessing it in here doesn't seem to actually cause any kind of problems. Right, so where are we now? I still don't understand why the machine is crashing, but having AGFA monitor on the Amiga is actually really exciting and really cool. And what I think I'll try to do is we're going to try to get some versions working for other versions of the Amiga that can run directly as ROM replacements. What's really fun about AGFA monitor is you can load programs into it using S records, just paste them over the serial port, just like I was doing on the AGFA. So it's perfect for any little test routines and stuff you want to run directly on the bare hardware on the Amiga that you just can't normally do. So to try to get again to the bottom of like what's happening with the Kickstart ROM, what I've asked my viewer to do is take a look at the actual routines that are running in the Kickstart ROM during that light gray phase of the initialization. That's where this thing is crashing and giving us that yellow screen. And to replicate that in a new Kickstart ROM that I could load using the Super Kickstart off a floppy disk. But the difference is, instead of just giving us a color screen that's useless, why don't we output what it's doing over the serial port? Because we know the serial port stuff is working now on this Amiga, because we just saw it working. And then we can let it run through all the steps that the normal Kickstart routine does, and then we can try to figure out exactly what it's trying to do when it's crashing. And that, dear viewers, is exactly what I have on this disk, so let's give this a try. This will hopefully be the first clue as to what is going wrong with this computer. So we're going to turn this machine on. This will boot us right into the Super Kickstart boot menu. And let's get our serial console up and ready. And you can still see the Amiga screen as it loads. Here we go. Here we go. It's booting. Oh, bus errors. Tons of bus errors. Bus errors caught at these program counters. And this diagnostic is configured to just sort of complete, even though that's not really useful. It just happens over and over and over and over again. And then all diagnostic stages complete, and real exec would now call start exec. Well, we know that it got to step 11 and that passed. Step 12 is where it fails. So what are these steps? Well, my viewer has given me this file here, which lists all the steps that we get. And step 12, SCSI probe. Right. So this is our first concrete evidence that our problem is with the SCSI controller. Now, the weird thing is how come when I was running in the AGFA monitor and I talked to the SCSI controller, it was working, and yet whatever the Kickstart is doing is not. It could be the way the chips are configured, like on the motherboard, like maybe Gary, which Gary is what selects the SCSI chip. Maybe there's like a timeout setting where it expects a response, and if it doesn't get it, it throws an exception. I don't know enough about the way this thing works. So this kind of leads me to believe, like, what if the whole time our issue was, well, maybe this SCSI controller is just dead? So a little bit of time has passed, and I've been taking this time to work with my viewer on refining this new port of the AGFA monitor ROM to the Amiga so that we could do some really thorough diagnostics on the Amiga 3000 and try to get to the bottom of exactly what's going wrong with it. Well, part one just went up to my patrons, early access, and I was looking at the comments on Patreon, and a couple comments said something that kind of shocked me. And well, it might be what the problem is with this computer entirely. The comments mention that on their Amiga 3000, if they don't have this riser card connected to the motherboard, they get a yellow screen when you power on the machine. I'm shocked by that, if that's the case. I haven't tried this yet. I'm going to try this on camera, but I read that and I just was in disbelief. How could that be? There are two TTL logic ICs on here, and I looked at the schematics for this. And in fact, let's do that before we even plug this in. But I looked at the schematics earlier, and it looks like those have to do with the auto configure for Zorro. But that's it. They don't really seem to be used for anything else. I don't think they're connected through to the motherboard, for instance. So I don't really get like how the computer could tell if this was in or not. And unless, for instance, like these pull-up resistors that are on here, or maybe pull down, or whatever these resistors packs are doing, are helping with the boot process, I just don't see how this thing could cause the yellow screen. But it's totally possible. And I don't even, to think about that, if that's actually the case, I'm shocked. I don't know how many computers I've worked on in my life that have these riser cards. I'll grab one here that's very typical. This is like an IBM PC riser card that would be in a PC clone. And I've worked on so many machines with these cards. You don't have to have this in the computer for it to work. You can unplug this and it works fine. First, let's start with this original scan of the Commodore schematics. This is for the Amiga 3000. This is the one I looked in and found that there was an older revision of the motherboard that doesn't apply to the one that I have. Oh, look, there's a picture of the card right there, E3000 daughter board revision 3. Anyhow, a few pages down, and it talks about the different slots that are available. Now, I'm pretty sure that this one, which is labeled CN600, is actually what's on the board. Yes, that matches what's on the board. So this is the connector on the motherboard. And then scrolling down, these are the connectors that are on this. Now, oddly enough, CN600 through 604, but this board, it only has 4 Zorro slots, Zorro 2/3 slots, and this diagram shows 5. And oh, if Amiga 3500. Okay, I think the 3500 ended up being what became the tower. So maybe further down we have some other slots, or another diagram, I mean, for this riser card specifically. Is this it here? Yes, here we go. Edge connector plus 4 slots. Okay, so this is it. Now, when it comes to the various TTL logic ICs that are on here, there's a 74HCT32, and this has to do with the Zorro autoconfig. Pins 11 and 12 make up the autoconfigure for Zorro, and these signals kind of allow the cards to only talk one at a time. And I don't think this chip is even connected to the motherboard. If we look at 11 and 12, those signals don't even make their way to the motherboard at all. So 11 and 12, there it is. Nothing's really happening. And you'll notice here that 12 is hooked up to something, but this is actually just hooked up to the negative rail, or ground, that is. So it does not make its way over to the edge connector that goes down to the motherboard. 11 and 12, as you can see, are just hooked up to ground. Go to the bottom here, that's ground. Now I'm noticing actually that it only lists that one IC on this entire riser, and this riser definitely has 2 ICs. So this must be an early revision. Now, I am aware of this recreated schematics. This came from 2014. This has a slightly different riser card schematic, and I've also compared what's in this to the Amiga 4000, and they appear to be the same, or similar at least. So here it is. Very similar, 4 slots plus the edge connector, but the one difference is this has a 7407 part of that auto-configure circuit. Oh, and I'm noticing here that the 7407 also plays a part on whatever this pin 91 is. But again, I don't think this has to do with the motherboard. The motherboard is just hooked up to that line, which what is that, just ground? Oh, it's a 5K pull-up. Interesting. Okay, well, anyways, all the slots, though, go through this, I think that's an inverter, 7407. This card does have the 7407, it's right there, and then we have the HCT32. So this is obviously the later revision that matches the schematics that we were just looking at. Now, when it comes to the Amiga monitor, the Agfamon port, and the diagnostics that we've been trying to create for this thing, where I showed off the diagnostics running that we had created, and it sort of was getting stuck and maybe indicating there was a SCSI error, I think that was a problem, or I think that was a bug in the diagnostic software, because it was very early days. It was just sort of thrown it together. And I don't think that that was actually a realistic error. Since then, we have made a bunch of iterations on the ROM, making it better, more capable, and also refined the diagnostic routines. Now, because we're working with a subset of just one machine, this one, running the diagnostics, I haven't been able to compare it to another working machine at this point. So I don't really know what it should look like versus this one. But let me fire up the current iteration of the diagnostic ROM so we can take a look at what the output of it is. And I can show you around the ROM a little bit, the newer, more improved version. And then I suppose I can plug this card in and see if it changes anything on the diagnostic ROM. And then we can switch back to Kickstart 2.04 and see if that changes anything. Oh, by the way, and there's one other thing that happened is the floppy drive I was using broke. It was an Amiga 1010 floppy drive, I think by Mitsumi, or maybe it was Neutronics. And it has this plastic sled that the disc itself slides into. And it has these little pins on the side that are all made out of plastic, and they sheared off just randomly. I put the disc in, and I think I went to eject it, and then the eject button didn't work. And I was like, what's happening? So this is a TIAC floppy drive, just a 1.4 meg one. And some of these TIAC drives are good because there's a bunch of jumpers here, and I kind of figured out, looking at the manual, how to use this on an Amiga, and this is working now. I don't know if it's working perfectly, but it works well enough for me to at least load the Super Kickstart discs. Okay, so let's power up the computer here. Now, the diagnostic ROM disk that's in here is emulating Kickstart 2, so I just have to do this, and it's actually going to load. Well, it thinks it's loading Kickstart 2.x, but it's actually loading the diagnostic ROM, which is what you're going to see running in just a second. All right, so here it is. Now, one of the problems we have is that it's using too much of the overscan area, so the stuff on the bottom is actually cut off. But that's actually fine because I have PuTTY open here, and everything that comes out on the screen is actually mirrored to the serial port. So this ROM is replicating a lot of what Kickstart does when the machine first powers up. So it's checking for the machine type and, I don't know, Ramsey version, CPU type, free FPU present. The ROM checksum. I don't think that's working properly at the moment. Ignore that. It installs some exception vector handlers and verifies that they're there. It looks for some exec base. I don't know what that is. It's checking for how much chip memory there is. It's saying the first failure is at 100000, and that's because there's only 1 meg of chip memory on here. If it was 2 megabytes, then this would say a 2. Now it's checking out the SCSI controller, and it is able to read this register DD00F or 40. It's getting back an FF. Whether that's right or not, I don't know for sure at this point. It knows it has an ECS Agnes. It's checking the CIA timers. Of course, the serial port itself is through the CIAs, so that's working anyways. It's trying to talk to the clock calendar, which of course is not there. It's doing another communication with the DMAC IC, the Super DMAC. That's this one here. This is what's used for talking to the SCSI controller. Weirdly enough, the order this is all happening in is the same as what Kickstart is doing, which is weird because the DMAC, this chip actually is required to talk to the SCSI controller. So it should talk to this first and make sure it's working before talking to the SCSI controller. But this is the way it's actually running inside actual Kickstart. And then it goes and tries to look at the Zorro2 autoconfigure space, which is a E80000, and that's actually generating a bus error. So that would normally crash the computer and might well be why it's crashing, to be honest, with the yellow screen when we're trying to run Kickstart 2.04. There are 2 modes you can configure the Gary chip. This is Gary, called Fat Gary on here, but it's just regular Gary on like an Amiga 500 or 2000. And Gary has some registers where you control whether bus errors, which is a state of a 68,000 processor, is generated, or whether DSAC is generated. DSAC is like an acknowledgement that the bus operation continued or worked, I mean. And right now, if you have Gary in the mode where bus errors are enabled, Gary generates a bus error when you try to talk to anything in this address range. If you change it to DSAC mode, then it just returns an FF. If you take a look at that memory, like say I'm using the AGFA monitor to dump the RAM, it would just return FFs. There's another check for Zorro 3 auto-configure space. It's not doing it in here. I would be step 19. I can't remember why we took it out. It's always getting a bus error no matter what. It would do it in both modes, BER mode and DSAC mode would both generate a bus error. And the program counter just is the location in ROM of the code that's running that's causing the bus error. So if you go look up your assembly language code and you look at what instruction is actually at that location, you'll see the move instruction or whatever the instruction is that's trying to actually access this particular memory location that's causing a crash. Now, if you had a normal Kickstart ROM running and you got a bus error, you'd get like a Guru Meditation flashing error message. Well, of course, when you're running your own custom ROMs, not these ones, but the RAM-based ROM that we loaded off the floppy disk, we can handle crashes however we want to. And that's why this doesn't actually crash the ROM. It just notes that, yeah, we got a bus error and we didn't get one in that mode. And what the yellow screen is when using the Kickstart is that the exception handler that is going to handle something like a bus error or any other kind of processor exception like a legal instruction or address error, things like that, well, it just turns the screen yellow. It doesn't give you any output. It could just output to the serial port what the problem is directly, but obviously, you know, consumer PC, consumer computer, they didn't want it to be, you know, full of diagnostic messages, which is unfortunate because they could have just printed it right to the screen like a PC might do, you know, with a text mode. They could have done that as well, but they just decided to go with these color-coded error messages that don't tell you anything. So this is the ROM actually starting. Now it detected the fast memory. It looks like we have 4 megabytes, but we actually only have, well, 3.5 megabytes available to us. And that's because 512K is used to map the floppy-based ROM image that's loaded into the RAM, you know, to replace the ROM. So that's why this is not 4000 or 400000 on both of those. And if we hit a key, it will then go into AGFA monitor, and this is the AGFA monitor that I kind of showed off before. It's been tweaked a little bit. It's, you know, has some formatting issues here and there still, but we can now look at long words, for instance, as opposed to just bytes. So just some different ways of formatting, and we can also write to memory as words, as long, which is 32 bits, or as bytes as well, which is 8 bits. Same with the fill and the copy command. There's an I command here, which just shows us a little bit of system information. So Agnes version, Ramsey version again, chip memory top, fast RAM stuff. Still a bunch of stuff that's like work in progress here. What does work as well, which is kind of exciting to me, is the S record loader. So this is just like with the AGFAs. If you watch any of those videos, it allows you to assemble a little program and then save it as S records. And with that, you can paste that in to the Amiga. So even though we're running bare metal, no OS or anything on here, just running out of the Kickstart ROMs. And right now, it should set the program counter automatically, but it's not doing that. So there we go, a little fractal generator. And there is a tick counter that is maintained, and it's using, I think it's 60 hertz on this machine, although I can't remember exactly. This program, which was ported over from the AGFA version, it's just a little assembly language program to generate this fractal benchmark. And yeah, pretty much ported right over to this, because while the entry points for like printing characters and getting characters from the terminal are different, like the addresses are different, that's really all you have to change if you're porting something from the AGFA that was running like in the machine language monitor, in the AGFA monitor. The entry point addresses need to change and the org needs to change. Anyhow, going back to the diagnostics that run, the only thing that I'm thinking maybe wouldn't happen with this in there is maybe we won't get this bus error trying to access this memory. And I will demonstrate that if we try to dump that location, it should just crash with a bus error. There it is. There's our exception. Now on the Amiga 3000 and 4000 and probably the 1200 as well, there's also some memory at the very top of the address space that's used for the Zorro 3 autoconfigure. What autoconfigure is on the Amiga is it's a way for the system to kind of initialize the installed cards. And that E8 space I just looked at, that was autoconfigure ROM space for the older Amigas. And this is the autoconfigure space for Zorro 3 based Amigas. And that just instantaneously crashes. If you notice when I go to this autoconfigure address, this is in the 24-bit address space, it actually doesn't crash immediately. And that's because Gary has a timeout setting you can set to wait a little while before it generates a bus error. Watch, I'm gonna hit enter and you'll see it print a little bit and then it will crash. See, FF, and then it crashed. And I mean, believe it or not, it actually read one address and then it crashed. Compare that to up here. If I try to read this space, it'll just instantly crash with a bus error. See, instantaneous crash, no delay whatsoever. The only possibility that I could really see is that that bus error behavior that we're seeing right now will be different when I plug this card into the motherboard. That'll be a good telltale sign. Now the Gary, or Fat Gary on this machine, has a couple registers you can set, and DE0000 is one of them, and I think I could change these to that. And now if we take a look at the auto configure space again, notice it doesn't crash. It doesn't do anything but just print FFs. If you look at the datasheet for the Gary chip, I was just telling it by altering those registers to not generate the bus error signal, which goes to the CPU and then causes that exception. Instead, it generated a DSAC signal, and DSAC, if you can imagine that, that's just like the chipset saying to the processor, yep, okay, everything worked out. That is a valid address you're trying to access. So changing those registers does allow me to read that memory. But what it doesn't allow me to read is the memory up in the 003 space. That's still crashing. I don't know what chip is generating this particular bus error, but I don't think it's coming from Gary because I just configured Gary not to generate bus errors. So it must be coming from maybe the Buster chip, which is this one down here. This is the chip that manages the 0.3 and 0.2 implementation on this computer. So I suppose here we go. Let's just put the riser card in. Does it only go in one way? Yep, there we go. My only hypothesis for what might change is not getting those bus errors in the 2.0 and the 0.3 auto configure areas. That's the only thing I could see possibly changing having this riser card connected up. And it might explain actually why Kickstart 1.3 works, because Kickstart 1.3 does not look in the 0.3 auto configure space. That would have to be something that Kickstart 2.04 or higher does. So that could be what's actually going on here. Right, so to get started here, we click floppy, and that should start loading Kickstart 2, which is actually the Amiga monitor ROM. And here we go. Let's see what this does. I'm very curious about this. I mean, this would be a very unexpected solution to a problem. Here we go. No bus error. I think that was it. That was literally it. No way. See right here? Bus error mode. That meant when Gary was configured to generate a bus error when you're trying to talk to that part of the memory location, it generated it previously, but now it's not generating it. So the trick will be, if we take a look and we try to look at the FF00 space up at the top of the memory, that 0.3 auto configure space, if this does not bus error, this has got to be the problem. This has got to be the problem. I'm saying this because Kickstart 2.04 looks for 0.3 autoconfigure. Kickstart 1.3 does not. And we can make the assumption that Kickstart 1.4, the version that, these funky ROM chips that are on here, also does not. So if we don't get a bus error here, this, without a doubt, is the exact problem. Oh, we still got a bus error. Oh, very interesting. Okay, so that still generates a bus error, but what does not generate a bus error is this right here. 0.2 autoconfigure in BER mode. With this riser removed, you get a bus error. Maybe what's happening with Kickstart 1.4 and 1.3 is it has Gary set to the DSAC mode. Yeah, I mean, that's the only thing I can think of. And it's probably these resistors on here that are making all the difference. Just so we can compare, I'm going to turn the computer off. Let's pop the riser out and let's just double check for sure that the bus error comes back with that riser not in the board. Okay, here we go. It's almost loaded. Takes just a second. It's like bated breath here. Here we go. Yep, there it is. Look. 0.2 autoconfigure, bus error. So a bus error was generated trying to access that when Gary was set to bus error mode. And with this in the machine, it did not generate a bus error. And if I'm loading Kickstart 2.04 and a bus error is generated during that phase, that initialization phase, which honestly, all this stuff that's happening right here happens in Kickstart 2.04. It does all of this stuff. If it does all this and it gets to this last step here, Zoro 2 autoconfigure, and it gets a bus error, that would cause a yellow screen without a freaking doubt. That is so freaking unbelievable. Wow. All right, well, it's the moment of truth now. I just need to put this thing back in and let's load Kickstart 2.04. I can't even, my brain is, yeah, okay. It's not like we're out of the water yet, but this is the first time with this machine where I've actually been able to see a change. And the cool thing is with this diagnostic ROM that we're working on, we'll just add a line in there that if it detects a bus error with the Zoro 2 autoconfigure, if it says Amiga 3000 is riser installed, and probably 4000 as well, like it would just say that because that seems to be what's going on here. Okay, so riser's back in, and I have the Super Kick disk that has 1.3 and 2.04 on it, all ready to go. We'll just get the diagnostic disk out, swap that over. And here we go. Moment of freaking truth. My mind is blown with this. Here we go. Kickstart 2.x. Is this going to work? I assume it's going to work because we saw a bus error being generated accessing the Zoro 2 autoconfigure space. And I don't know. I mean, Zoro 3 was still generating a bus error. Maybe that's just a given. I don't know. But let's see what happens here. Wow. Wow. I mean, thank you very much to the people who commented that, the patrons. Here we go. Wait. Oh. I mean, I'm at a loss for words here. I am at a loss for freaking words. Okay, let me think about this for a second. So, when I got this computer first fired up, after I cleaned up the battery damage, remember what it was doing? This was back in part 1. It was just freezing. Kickstart 2, with the Kickstart 2 ROMs in there, you'd get the dark gray, then the light gray screen, and it would freeze. My assumption is that was a different problem. And this yellow screen issue started happening once I reseated all of the custom chips, putting deoxit in the sockets. So I'm assuming we had a bad connection in one of those sockets that was causing that freeze. Once I put the deoxit in there, we were getting further in the diagnostic routines, all the steps that were happening. And I think what was happening was it was getting to the Zoro 2 autoconfigure, and because the riser wasn't in the board, we were getting a bus error, which would cause the yellow screen. So I was dealing with a couple different problems there that, wow. Wow. Just wow. I don't even know what to say. So, okay, well, if you have an Amiga 3000 or a 4000 and you're working on it, always freaking put the riser card in there. Because if the newer Kickstarts, it will crash. Why don't I not count my chickens before they've hatched, so to speak? I'm going to take the Kickstart disk out and let's try to load Workbench 2.05 on this machine. I think the issue with my floppy drive right now is it is not able to detect a changed disk. So I'm going to have to plug a keyboard in. Incidentally, my keyboard also broke, the one I was using, so I had to grab another keyboard, which is what this one is. Everything is breaking here on these Amiga episodes. There were some corroded traces inside the keyboard that was causing an entire row of letters not to work. Anyhow, let's reboot the computer. I think that should make the disk drive at least load once. But yeah, I lost the floppy drive. I lost the keyboard. I've had all these issues with the lack of a riser card. I mean, at least we have a diagnostic ROM that came out of it, right? That's something. It's loading, by the way. The TIAC floppy drive is very, very quiet. You just can't hear it actually seeking, but I can hear it very faintly ticking away. I know we have no clock calendar and the flicker fixer is all broken or whatever. There we go. There we freaking go. Yes. I still can't even believe it. all of the trouble was because of the riser. Okay, I'm going all over the place right here because my mind is reeling from this. First off, huge thanks to my patrons who pointed out this exact problem and told me that this card needs to be in the machine to get it to load. Oh, anyways, I don't even know what I was saying at this point, but I guess the positive of all of this is that we're going to have a better diagnostic ROM for Amigas that should be able to tell you a little bit more about what's going on with your system. But I want to test the hypothesis that, for instance, if I take out the SCSI chip or the Super DMAC chip, this has to do with the SCSI subsystem, that we get that freeze. Because I'm still kind of thinking that the freeze is probably related to these. Although I don't really know. I'm talking about the freeze that I was getting in part 1 before I reseeded everything and then we started getting the yellow crash. So here is an interesting tidbit that also just happened today. A few hours ago, I got an email from James. James is the person that gave me this Amiga 3000. This was James's actual computer for a while. I don't know how long James had had it, like if it had been from the 90s or what, or if it was a more recent acquisition. James definitely used this computer and said it was a good computer and it worked well. Even with the battery damage that was on there, the machine was functional. James gave me a couple really important caveats though. James said that the flicker fixture output was always jittery and didn't work properly. So I'm assuming that was because of the battery damage that it's got. James also said though, the computer worked fine for a while, but then it started freezing. That was the symptom of this machine that ended up having James take it out of service and why I received it all in pieces. I think it had been that way for a number of years, simply because it was freezing. Well, what was the machine doing with the Kickstart 2.04 ROMs in there when I first powered it up after, cleaning up the battery damage? It was freezing. So I asked James for a little clarification to see if the freezing that he was experiencing matched the same thing that, I was seeing when I powered this thing up. Because if that's the case, that lends a little bit of credence to the fact that some of the custom ICs were getting bad contact in their sockets, and just the deoxit is what fixed those. I don't think James would have ever operated this thing without the riser card, so I doubt the yellow error was anything James ever experienced. But the freezing, that is quite possible. So I think my next course of action right now is to spend a little bit more time with my viewer, work on this diagnostic ROM, kind of refine it a little bit further. I'm going to make an actual set of ROMs. I'm going to burn some ROMs to run on this machine because I want to see it running without the whole Super Kickstart stuff. The reason why is because if I pull out the Super DMAC chip that's for SCSI, what happens is Kickstart 1.4 doesn't work anymore either. It sort of freezes as well. Well, I want to see what happens with the diagnostic ROM when I pull DMAC out. I want to see if we see an error or a bus error or some kind of a crash happening in that routine, something that we can handle. I want to try to make this diagnostic ROM as good as possible for detecting errors on these later machines. It seems to me one of the issues with the existing diagnostic ROM solutions for the Amiga and even the Amiga test kit is they don't really test all the components of these more modern Amigas, like the 3000 and the 4000 and the 1200 and the 600. They really are kind of targeting the 500 and the 1000 and the 2000, and which just is the basic 16-bit Amiga. And I think with this machine, with all these like Super DMAC and Super Buster and that's that and the other thing, that's where you start to kind of run into more potential issues. And I feel that the yellow screen on Kickstart, that people get with these later versions of Kickstart, and you're like, well, maybe it's this, maybe it's that, you're kind of all this guessing. I want to try to eliminate all that guessing. I want to give people as much information as possible with that diagnostic routine just to kind of see what's going on at that boot phase where you're getting a yellow screen with Kickstart. Well, there we go. That's part 2 of the Amiga 3000 repair series. What I'm going to do in the next part is I'm going to dive into a little bit more about why the Kickstart ROM is giving us the yellow screen when we have the riser card not installed. I already have some leads on what exactly is going on with it, and I should be able to demonstrate, well, why it's actually happening. In addition, I want to get back to fixing the machine, like what I was supposed to be doing before I got stuck on this whole yellow screen of death thing, fixing up the battery damage from the flicker fixer, or on the flicker fixer we have at least one bad trace, and then also installing the clock chip again. Obviously the machine doesn't need the clock chip, it will work perfectly without it, and it's not like I'm ever going to be using the Amiga to do serious work, but on the other hand, maybe it'd be kind of cool to try Amiga Unix, and I think with that you definitely need to have a working clock calendar. I corresponded a little bit more with James, who's the person who gave me this machine, and James told me that the flicker fixer never worked properly, and definitely the freezing that this machine was having was pretty much what we were seeing initially once I got this machine fired up, that gray screen where it never actually would boot up into the OS. So I think that kind of confirms that probably the issue was, even before I worked on this machine, was just bad contacts in the sockets, which of course Deoxit fixed. So if you enjoyed any part of this video, I'd appreciate a thumbs up if you didn't know exactly what to do. When it comes to the Agfamon, or the Amiga Mon as we're calling it, that's running on this thing, there'll be future updates to that, but right now it's too early to say release any of this code, but I definitely want to get that code out there and have it be much more enhanced. Stuff like additional RAM testing, like much more thorough RAM testing, because it doesn't really do anything right now, and more diagnostic information would be amazing. Having a RAM check that could run on this thing, like to check your chip memory, and then flash the LED, for instance, to tell you which bit is bad, that would be ideal. I don't think any of the existing diagnostic ROMs do that, although maybe they do actually. I'm not totally sure about that, but I'd like to add March RAM testing and stuff like that to the diagnostic ROM and other capabilities. So yeah, there we go. Thanks to my supporters. Thank you to you for watching. Thank you to my subscribers. If you haven't subscribed, to hit that button, and you know, comment down below and all the other usual YouTube junk. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.